Well, hello there. Welcome to the stream. We're going to get right into the coding because that's what I was doing right before this. Well, actually, right before this I was sneezing for some reason. But I was coding the stats and skills update. Got some cool stuff going on here. Figured out all the problems from the last time I was streaming. And now things are working. We're going to have to come back. This circular logic thing, this happens when you click paste. I've already copied another stats and skill item. And when I click paste, it pastes it in. However, one of the things that it pastes in, one of these sources, is leather. Now, leather can't be a source of itself. Hello, Aaron. How are you? Leather can't be a source of itself, nor can it be a target of itself. So we could not do that. Now, what I'm not yet checking, though, is actual circular logic coming from multiple stats and skills. So we're going to test that right now to make sure that we can't accidentally add circular logic. That would be where A affects B, and B affects C, and C affects A. Therefore, you can never actually come up with a conclusion as to what the final value would be because they keep affecting each other. It's one grows, the others would grow. So we need to check more than just whether it's this object. Nice. Congratulations. That's always a good feeling when things work. I know that feeling not as well as I would like sometimes. So we have hit points and other things here. That's cool. Time-saving tools. Spend hours up front to save more hours later. Makes sense to me. Let's see, we've got all these things here. So I'm going to have skills. We've got bodybuilding. And bodybuilding, you can now delete stuff too, by the way, which is really cool. So bodybuilding is going to affect hit points max. Bodybuilding itself is going to be trained and modifiable. And I'm going to duplicate this, and we're going to call this Skill Master. And Skill Master is going to affect bodybuilding. So I'm going to remove hit points. I'm going to add bodybuilding. And we're going to say that Skill Master affects it this much. Actually, yeah, if Skill Master, so bodybuilding, add, I forgot to copy, affects it 1 per base and 1 per skill point. Just some random number. So I'm going to copy this and just paste it to all of these just so they're all kind of the same. Bodybuilding, same deal. I'm going to copy and then just paste these so they're all kind of the same. That won't matter for what we're doing, but it's just nice. So Skill Master affects bodybuilding. Bodybuilding affects hit points. But I'm going to say that bodybuilding also affects another random thing. So I'm going to call this we're going to call this random skill. And random skill is going to affect Skill Master. So you might see where we're going with this. Alright. So now, random skill affects Skill Master. Skill Master affects bodybuilding. Can bodybuilding affect random skill? It can. Now that would be circular logic, so we want to avoid that. And so this is going to take a little mental gymnastics. I've done this before. Essentially, we need to build a tree, as Jason Storey would point out, a tree where, or something like that, where each skill, stats and skill, knows what it affects, and really the more important thing, knows what affects it. Oh yeah, you like the demon dog? Thank you for watching it. That's always helpful. The long streams, you know, don't get too many watches after the fact, but I do wonder how much people liked him. Yeah, blue tongues. So how are we going to do this? I have a method already on here on the stats or skills modification level. Can add modification, and it's where we're going to check things. But we need to see. We have sources and targets, and let's see. Effects. Do I have effects list? And an effects list. But this is not the full effects list, is it? No, it's not. So we're going to build a public list, stats and skills. We're going to call this affected by. There's new list, stats and skills. And we're going to do another one called effects. So stats and skills that affect this object, and stats and skills that this object affects. Okay. I don't think we need these anymore. Okay, and then we're gonna build these. So I suppose underneath these methods, we'll say private, maybe public void build effects lists, and let's see. Well, I guess what we're really looking for is to go through we need to find which objects affect this one, and then which objects affect those, and which objects affect those, and so on and so forth. So let's see. Let's do a new list. So we'll just do var list stats and skills, and we'll call this branch list for now. And this is going to be essentially the sources. No, not sources. Call this we need to find out which ones are affected by it. I suppose I'm going to comment this out for now. I suppose when we add something here, we should be doing something there. So let's do that when we add, and I'm gonna actually put here, we got can, if not can add modification. What are we looking for? Okay, best practice to do that, but maybe we'll do it later. So when we add a modification, we're adding a new target, and that's stats and skills. So what we should do is say new target dot effects, or is affected by, or effects list dot add this object. That won't work. That won't work because I don't have access to this object. I need the access of the parent of this object. Now, in other ones, I've been passing that in. As such, so I could continue to do that. We could just say if this object is not equal to null, then do this. Okay, and that would add this object to the effects list, and what we can do, if new target dot effects list dot contains this object, then we'll do, oops. So if it doesn't contain this object, then we'll add it. If it already contains the object, then we won't add it. That's not going to work either. That's not going to work either because when I hit this X, I'm going to want to do a remove, and that won't always be the case. Is that right? I'm going to call this affected by. That's more accurate. Affected by this object. I'm not going to put an add modification. That's the wrong spot. It's the wrong spot. Let's see. We're going to do it on, let's see, add. Let's see. I'm going to try doing that here. Let's see if that works. So it's going to be very similar. target is this. So we say, so var target equals that, and we'll just say if target is not affected by this object, then target affected by add this object. Okay. And similar code for the other add. And source. So let's think about that. If something is a source, then this can't affect that something, because that would be circular. But the goal here, like let's say that you have some weird thing that once this loads, let's say that you have a main stat called gold, and we'll just call this gold, and gold can't be trained, can't be modified. The value of gold would be basically points. And then let's say you have a skill called Goldmonger, and Goldmonger can be trained, can be modified, and what's this? I was hoping I wouldn't find another thing. Okay, well, there we go. What's it saying here? The index is out of range, so this is out of range of this. It's saying I use it right up here. Can I put this higher and maybe then add this right here instead? Oh. Okay, yeah, that's, I need to, that's silly me. Silly me. That needs to be inside the button. For music, let's see what's playing right now. If this is what was playing before, this is the music that comes with the Anubis pack. Masterfully composed by Nathan Cleary, and we can look him up. Nathan Cleary music. Oh, on Apple. He's got music on Apple. See? Infinity PBR selected works. He's named them slightly different than me, but that's okay. He can do that. So Nathan Cleary is the composer of the music. And the music comes in. You're up at 5 a.m. Good. Congratulations. That's good for a Saturday morning. Yeah, so that's where I get the music from. I haven't gotten any new music from him for a while. It's fairly expensive, and I don't think there's a return on my investment. I think people like the music for sure, and it's valuable, but there's like 20-something tracks already, 30 tracks, something like that. But it's just too expensive to get more made right now. So right, so put this down here. There we go. So both of those need to be inside the button. All right, so as I was saying, let's say we have this Goldmonger, and Goldmonger is going to affect hit points max. He's not going to affect him by the base value of Goldmonger, not going to affect him by the per skill point, but by gold. So now you could say that for every gold you have, hit points max goes up by 0.01. So for every 100 gold you have, your hit points max is 1 higher. As gold goes down, hit points max will go down. In that regard, you could create a gold monster in your game where instead of attacking it with your weapons, you have to steal its gold. And the more gold you steal, the weaker it gets until you steal all of its gold, then it dies. So you could do a cool thing like that. Which is really neat. So the point is, what was the point? I forget what the point was. Oh yeah, I think the point was that the hit point maxes should now be affected by gold. And affected by Goldmonger. It needs to be affected by gold and Goldmonger because, yeah, that's why. Because now hit points max, if it was something that itself could affect things, you don't want that affecting Goldmonger or gold, or anything else that affects Goldmonger or gold, because then you get that circular logic. So when we add something here, we need to make sure we add both of these. Yeah. Okay, so what we added before was this object. So the target hit points max is affected by that, and so we need to. I mean, there's no way this object is null, right? Yeah. So we can move this out and add this object to the other objects, to the targets. It's affected by list. Okay, and then on our other add, we're going to do this, and instead of what we got here, should add source. So this is the source, and it's going to be affected by this source, and we're going to say it's really going to be all targets. So we're going to have to do a for each stats and skills target in targets, or this object dot targets. No? Dot modification. No. Oh, it's defined below. Ah. Delete that. That's not supposed to be there now. Modification level. Dot targets. For each target and targets, we're going to say that target is affected by the source we just added. I'm just thinking. I think that should be fine. I mean, in an ideal world, I really want one method that would just do all this rather than doing it at the point of add. I think it works on the point of add, but I prefer one method. But the problem is that, well, that's very difficult to go the other direction. To say, hey, hit point max, what affects you directly? And then, hey, hit point max, what affects those? But I guess you could do that too. So this is fine, but let me try to do that because I think I would prefer if this could build its own. And I've got this method down here, build its own list. So what we could say is, don't want it to take tons of time though. Even at edit time, this could take a bit of resources, especially if I use link. What I want to do is I guess I could put build effects list actually in here. That would make it a little bit easier. And I might want to limit it at some point, but for now I'm not going to limit it. So we're going to say for each stats and skills in get modifiable array. So this is going to get all the stats and skills in the project that are modifiable. So only stats and skills that can be modified will end up in this row. And those are the only ones that will have an effects list, because and so this is actually going to be affected by. Okay, so affected by list. Yep, and then we'll do effects, and we're gonna have to do that separately. So affected by, so for each modifiable stats or skill array, we're going to let's see if we can do this. Stats and skills dot okay, start with this. Get stats and skills array dot accept got the code somewhere. I want to copy this somewhere. Where is the code? This one. Accept this. Accept this object. Okay, so stats and skill array, except for this object, where or select many. Where I remember not liking this part when I did the stats and skills the first time. Where or select many, I'm not sure which. So every stats and skill, we're trying to see if it affects the stats and skills. And if so, add it to the list. So x dot guess targets dot mod levels. Oh yeah, I guess we're really looking at the modification levels. Then dot select many x dot targets dot distinct. So all the targets in all the modifications level of every stats and skill we need the where x put that here. No. Okay. So all stats and skills, except for this one, select their modification levels and select their targets from those, where the target equals this stats and skill, and then distinct of those and really we're looking for get trainable stats and skill array, because only the ones that can train can affect others. Distinct. Okay, we'll say var all that affect this equals that. All right, so all that affect this, and then we also want to look at sources. So if we go back and do sources that affect this, we're going to say get we're really selecting many targets. Can we do an and? So I guess what we're looking for then, if we have a list of all the effects, what we're getting is this right on. So get trainable stats and skills array. And if we're looking at this, what we're really looking to say is, you know, affected by, we want hit points to realize it's affected by Goldmonger. And so we're going to get all the trainable ones like Goldmonger. We're going to remove the one that's this, because just in case it is there, because it can't be affected by itself. And we're selecting all of their modification levels, which is 1, 2, 3, 4 in this case, and from there all their targets, which is this list here, where no, this is not right. This is only going to result in hit points max. We want the opposite. We want mental gymnastics. That's what apparently we want because we got it. Okay, what we're looking for is from the trainable ones. What we're saying is basically saying, is it in that list? So, where X dot stats and skills modifications levels. I guess we have to select that first, and then where contains, no, where X dot targets contains stats and skills. I'm going to rename that this stats and skills. So get the trainable stats, select all their modification levels where the modification levels contain that. That's not right either. That's not right either. Let's not use link. Let's go the old-fashioned route. How about that? So for each stats and skills, we can, okay, and then for each stats and skills, trainable in get the trainable ones. So if trainable equals this stats and skill, then we'll say continue, and then if trainable dot affects this stats or skill, so if trainable doesn't affect this stat or skill, continue. Now let's build that, and this is going to say for each stats and skills level, mod level in modification levels if mod level dot targets dot contains this stats or skills, and return true. Otherwise, return false. Okay. So if it doesn't affect it, then continue. So if we're down here, it means it did affect it. So we can say that, let's see. What did I do before? Because I know I did something before. Stats and skills branch. What is a stats and skill branch? Skill tree. Oh, so the skill tree is just a list stats and skill UIDs. Okay. And this is a list of lists. Okay. Oh. Okay, we can make use of this, I think. Okay, let's keep going, because what we want to do dot branch tree skill tree dot clear. So we're gonna start by clearing the current skill tree, and that's what we're gonna rebuild. And then we're going to build the first level, which is this. Build first branch of skill tree. It's more like roots, but that's okay. For each trainable one, continue if it's not affected by continue. Otherwise, we're going to say, what was it called again? Stats and skills branch. New branch equals new stats and skill branch. New branch dot add, and we're going to add trainable. Public list stats and skills, stats and skills equals new list stats and stats and skills, and comment this out. I don't think it's needed. Oh, maybe it is. And then public Stats and skills. Yeah, no, that's fine. Okay. New branch dot stats and skills dot add trainable. Okay, so this will go through each one, and we also need to add in the sources. So for each stats and skills source in trainable dot sources, no, in trainable dot sources new branch dot stats and skills dot add source. Okay, so we need to make this, and this is going to be similar to the other one where we say each modification level bar sources equals so we're going to say list stats and skills sources equals new list stats and skills, and then each mod level sources dot add range mod level dot sources. I think that'll work. And then return sources. Sources dot distinct. So we only need one from each. So really, we don't need to do a for each here. We can just say new branch dot stats and skills dot add range trainable sources, and then dot distinct. We can distinct. Can't do that. Okay. Can't do that. Oh. There we go. Then make it distinct. Can't do that. To list dot distinct. Ah, it's like that. Okay. There we go. Alright, and then from here, so now we've got a distinct list of stats and skills that affect this directly. Now we just need to go through these and just add new branches until we can't add branches anymore, until we just haven't added any more branches. And we're going to go from the next one up. So this is important to think about because we need to make sure we're not doing a loop, infinite loop. So we're going to say int index equals 0 and bool found something equals false, and then or found nothing equals false, and we're going to say while found nothing we will say for each stats and skills, branch stats and skills in new, oh, we didn't add the new branch. This stats and skills dot skill tree dot add new branch. This will be index 0. Index. What does this say? Dot stats and skills. All right, so each stats and skill in this index. You know, at the end we're going to go index plus plus, and then we just need to find all the things that affect these. Now, technically, if we do this all the time, then we can't build in circular logic. So what we should be able to do is say we do new sub-branch. Then actually this is going to be up here. for each one in the branch, we're going to say add all of these, and at the very end we will make that distinct. I guess we can put it here. And then we will say if new sub branch dot count or dot stats and skills dot count equals 0, then we'll say found nothing equals true. Otherwise, and we'll break it to just to and then otherwise we're going to say this stats and skills dot skill tree dot add new sub branch, and that's going to keep doing then the next one, and we're going to keep doing that until we find nothing. And debug.log will add this stats and skills dot skill tree dot count to this next to branch index I plus 1 or index plus 1. We'll add yes, this is what we want. It's going to be just new branch. Yes, recursively, Elliot. Thank you for asking. Welcome to the stream. They could be fairly deep. I mean, I think in practice they likely won't get too deep. I know for my game they'll get maybe 3-4 levels deep, but technically they could get very deep. Yeah, that's it. Basically what I'm trying to do. And I need to call the method, but where am I calling the method? I haven't built the effects yet, just the affected by. So I think I need to call this every time I add or remove something. Let's try that. We can remove this earlier attempt. Build effects lists. X. All right. those are the 4 times that we should rebuild. I suppose we might want to rebuild every time one of these is loaded too, because if I copy one, it'll copy these values too, which means the new one will also affect them. But let's see. We're going to add armor class. And it's low. That's what I was afraid of. Or infinite loop, one of the two. Probably infinite loop because it shouldn't be this slow. I'm going to say that's an infinite loop. And by the way, Elliot, now that you said how deep are your skill trees, I've got How Deep Is Your Love in my head, that song. How deep are your skill trees? Your skill trees, skill trees. Infinitely deep. All right. Well, let's quit Unity then. And you know, I'm gonna say one other thing here. If index is greater than 20, we're just gonna return, just to get out of that infinite loop. Infinite loop. I think the break may have been messing it up. What is this? This is a new error. Alright, well I think that's unrelated. So where are my... Here we are. Yeah, okay. All right, so add a bunch of stuff. And it's clearly, this is where the infinite loop was. It just keeps adding. And you notice that this is like, I guess a bug or something, because the arrow on these is, you can only see the dot there, but it's there. Oh, skill tree size 0. Well, why is that? Oh, interesting. I think break was causing it too. I did notice that found nothing was grayed out when I had break. So maybe that's the same thing that was happening. Okay, starting armor class. Never ends armor class and never does anything else. Alright. Oh, you mean here? Break? Ah, you did mean that. Thank you, Elliot. Alright, but armor class. Main stats, armor class. Show full inspector. Skill tree. What are we looking at here? Alright, clearly I need to make sure that doesn't equal null. If trainable equals null, continue. That wouldn't make sense. Where x not equal null. Ah, I'm glad to have you here, Elliot. Always helpful to have a second pair of eyeballs, especially since I don't know everything. All right, so that should get rid of the empty one, but it doesn't explain why we are going here. So we're going to start debug.log starting on index. Go back to one of these. Just gonna delete this. Starting index. Okay, so it is going up. Of course it's going up. First index, 3 to branches, but it's getting the same stuff each time. Does it? 206. You must mean on the other. Branch stats and skills. This means 306. Oh, this one. 296. I got it. It's never used. Ah. That's why. Thank you. Good catch. Good catch. That is probably it. that would be it. So let's see. If I add armor class, starting armor class, we'll add 3 on, and then we go to armor class. Yep, hit points max. So now if I go to something, make something do chain. Or actually, now armor class cannot be trained. Okay, so we can do our skills. Alright, so skill master does bodybuilding. Let's add it again. And bodybuilding does hit points max. So does hit points max have in its list skill master? It does. Needs to have not this. Shouldn't be listed. Oh, okay, so we need to exclude any area in the top already. Not so. Essentially, we want to say, okay, get this, but then exclude everything else in the table thus far. And to do that, we will. Wait a minute. Why are we doing both of these? Okay, no, that's fine. And then we will say, so we add that. New sub branch dot. I'm just going to do another for loop. I know I can probably do some of this with link, but I'm a little noobish at link. So last branch in index -1. And we'll say new sub branch dot dot stats and skills dot remove last branch. Hey yo, Jason Storey. Oh gosh, Jason, come on. This is we didn't invoke you. Oh man. Yes, so you weren't here when I mentioned your name in reference to trees, because the other day on Wednesday night, I think it was, you were saying that you had helped me with something about a tree, and I was thinking to myself, yeah, that's the thing I'm about to start working on again. Yeah. And so that's where we are. God damn it. Argument out of range. A tree, you say, huh? My fear here is that I don't know what you mean by a tree. This didn't work. Huh. Interesting. Hey, Fanto, welcome to the stream. A BST? What's a BST? The anti-train conductor, huh? Well, I mean, it sounds like binary search tree, but I don't recommend that fancy. Just a standard tree. It sounds like this is something that I should learn, is what I'm hearing. That, you know, that a tree is something that clearly at least 3 of you know about, and I don't know. And that puts me at a disadvantage, and I should know about that. So, Jason, if you are ready to derail, then you are welcome to join me, and we can talk about this, and I can figure out how to make a tree out of this recursive search thing that I'm doing. Sound good? I mean, hey, it's Friday night after all. What else am I doing? Choo-choo. All right. Unity data tree. Well, see, not support tree structures. My notes. So this is what Jason was talking about. Lesson time. It will be lovely. All right. Oh, Tony, I like him. He's a nice guy. Makes dialogue system for Unity and other things. All right, I will be right back while I set up a chat with Jason. So hold on to your horses. Sorry about that, everybody. I was muted, and that includes Jason.
Okay, well, I'll give a quick recap. I was just saying we're going to do a big talk about collections, and so before we get to trees, which are a type of collection, we're just going to talk about collections as a concept. So to start, we'll say the basic building block of code is a thing. We'll say a string, just a string, right? And then obviously at some point you want to have lots of strings together. And so out of the box, you've got this thing called an array, and an array is just a contiguous collection of strings. And then you can say, get me the one at position 1, 2, 3, or 5, right? And so you basically block an amount in memory, and it makes an array, and you use it. Now, before we get fancier, let me ask you, what is the difference between a list and an array? We'll start there.
A list can be reordered.
Technically, you can reorder an array.
A list has built-in functions for reordering.
No. Okay, so share your screen and we'll do a quick thing.
All right.
This is a valiant guess. It's a valiant guess, though.
Yeah, I try,
Okay, so first we'll say the main difference between a list and array is, so what happens if can you call add on an array, basically, is the question.
No.
You're right, you cannot call add on an array. Why can't you call add on an array?
Because what I meant to say earlier was it's can't be resized.
There you go. Yes, that is 100% the answer. Is an array is fixed size. You literally say, give me 10 slots in memory, please, and I will use them for some stuff. But then list lets you say, YOLO, just keep adding things to and keep increasing the size. Now, here's the real kind of tricky question. How does it do that? What is fundamentally different about a list versus an array that lets you resize it and add new stuff to it?
I believe we've gone over this. I think the list is essentially just an array, but has fancier things that allow it to be modified.
Exactly, right? Yeah. And so what we can do is we can actually see this. So if you have any lists here anywhere, you can jump to one.
I'm sure I do. Maybe.
Well, and we'll do the whole like decompile the code and jump down a level and actually look at it, like I showed you before with the interfaces. Only this time we'll look at it from a perspective of what it does. There we go, list. Yes, click list. And here's the secret of how lists function is if you scroll down through this. I'm not sure how much of the source code we're going to see. Okay, so it's not decompiling it to the level I would like, but suffice it to say, behind the scenes, it is literally an array. And an array with a size, if memory serves, of 12, might be 8. There's some set size number. And the way it works is literally every time you call add, it checks if the size of the array is greater than the number you said. It adds it. If it isn't, it literally calls array.copy. It takes an existing array and it doubles it in size. So the only reason I bring that up is to say lists give you magical extra features that arrays don't have, but they're not magical. They are using the Lego blocks you have, but they're just wrapping them in additional functionality. And there's actually more than one type of collection. So one of them being a stack. And a stack is just an array as well. Only the difference with a stack is it keeps track of an index of the last position. And then as you start to add things on top of it, it only lets you get the one off the top. And you've got peek and pop and a few other different features. So I guess my point is, a lot of the default collection types are just arrays with extra steps. And there's other types of collections too, which brings us to one called a linked list. So let's talk about this philosophically and not about code. Is if we've established that an array is just a thing you can use, we can also make lists without using arrays. And one way of doing that is just saying, imagine I had a class called box, and box internally had one reference object called other box. And other box is null. There isn't another box. There's just one box at the moment, right? And imagine if I had 10 numbers I wanted to store in a quote unquote list. I could just store the first one in box 1. I could then add a box to box 1 called other box and put the second box in that one. and then I could add a box to its box, and I could just keep doing this, right? So it's literally my list. There isn't really an array behind the scenes. It's just a thing with another thing attached to it. And every time I want to add a new entry, I can add it infinitely. Now, what's kind of cool about that conceptually is suddenly we don't have a max size limit any problem anymore, right? Because a linked list is just a list. It's a way of storing things sequentially, but it's got different pros and cons. In this case, what's really cool about a linked list is if I jump to any point in the list, I can easily find the neighbors because I'm literally saying other box is from one side to the other. Does that make sense?
Yes, I think so. Except for the parent.
Yeah. So, well, yeah, you can store a reference to the parent as well. I guess my point is that my point is simply that you can make collections out of any combination of stuff you need. And likewise, if you're making a tree is just a thing with other things. As weird as that sounds. So a tree is like a directory structure. There's a folder, and it might have other things. One of those things might be another folder. And that folder might have other things, which might be more folders. And it keeps doing that. And so we'll make one just to demonstrate, but just to keep that in mind is that these are just extra collection types you can make. And there's lots of other ones out there. There's sets, which have unique entries, and then there's hash maps, which have their own properties in terms of unique references. There's a whole load of stuff. So I guess the point is to say, you're at the point now where the data structures that you're doing go beyond lists and lists and lists. And you're starting to hit that point where every so often you'll hit something and go, oh, okay, this has a list of children, which might have a list of children where I have to know how many there is and whatever. And it's starting to trip you up because it will trip you up. It'll trip me up because it's you hit a point where you're using the wrong tool for that job, and it's starting to get confusing because it's hard to know how many children there are. But the thing about a tree is the way a tree works is you don't talk to the layers of children. You basically talk to a node, and the node does the work down the line if there happens to be more. It's called a tree traversal, but that's a whole different conversation. So we'll just start really simply, and we'll demonstrate what this concept is. So I guess we can make ourselves a very quick generic tree. It'll be really basic, but it should hopefully prove the point. So if you just make a folder there, and we'll drop a few scripts in it, we can sort of build this up logically. Now I'm gonna make a little bit of use of generics, which is going to confuse matters, but the trade-off is once we're done, you can use this for anything you want later. We could do a really simple one to demonstrate it, but then you'd have to understand how to retrofit it for other things, and I'm going to make your life easier. And so if we make it a bit more complicated than it needs to be, you can use it for stats almost directly after we're done, right? Right, so we will start by making something called a tree. Now, Unity has an inbuilt tree, so I would call it like my tree or something just to keep things separate. Otherwise, it'll shout at you, whatever you want to call it. Yeah, fine. Because it's entirely arbitrary in terms of what we're calling things. Yep, so open this thing.
All right. Oh, I tried to rename it. Can I put it in my class or my namespace?
Yeah, go for it. I should probably keep the comments up at the side as well. Just so that I can see what people are saying. Yeah, at some stage we'll do the proper whiteboarding thing up, but I don't quite have the tools set up. On a side note, I'm hopefully getting fiber in the next few weeks, so that should allow me to have actual ability to share my screen more often. We'll see how that goes. So. First things first, you can remove mono behavior, remove the comments. It's just an empty object for now, and we'll start building it up. Now, the first thing that's interesting about trees is trees are actually like a top level wrapper. That's actually the least important part of the whole system. The node, as probably described earlier, is probably the most important part of all of this. So the next class underneath this, we'll just call it a node. And this one you can just call node. You don't need to call it like module node, just node is fine. Right, and now we'll get to the first bit is generics. So do angle bracket T like you would with list at the end of node, the end of tree.
Okay.
Now we'll come back to this because it's not super important, but that's just how we allow this to be sort of supported with other stuff. So the first thing to note is a node is going to have inside of it a list of nodes.
Okay.
So just list of node T, and we'll call it children.
If I can spell. There we go.
And that bracket is that goes inside the other one. So it's node T, then closing bracket. Yeah, perfect. These are the children. And so next we need a constructor. So on the next line, you can go CTOR, press tab, and it'll auto fill that in for you. Yeah, and you can just say children equals new list children. And so from a design perspective, all we've got here is something called a node, which is a bunch of child nodes. And currently it could have none, but you could also have some. And then finally, we'll just make an add function, just like you would with a list. So you can say add, so public void add, and we'll add node of T. And so inside of that, brackets for the round brackets there, we'll have node T.
Oh,
and exactly, and we'll add to it. But yeah, you're 100% right. That's what we're doing. We're just adding to that.
Okay.
Yeah, and call it node or child or something. Yeah, exactly. Perfect. And then add that.
There we go.
There you go. And it's void, public void add, and we'll add our node. So that's that. And then something I like to do, probably overkill, but we'll just add a bit of fanciness. On line 12, you can say implements IEnumerable of node T. So full quote, yeah, exactly. Yeah, no, you're right. Yeah, and IEnumerable. And then inside of that one, node T inside there. Yeah, and it'll ask, press Alt Enter, it'll ask you to implement that.
Aha.
Yeah, and you can just press Enter for that. And this is one of those, we won't talk about it, but it just does magic. So you can just write return children.toList, children.getEnumerated, sorry. And that's just a nice bit of sugar, which we'll come back to later. So that works. Okay. We have an add function, we have a thing. And then the last one is we'll make a quick function and we'll call it traverse. So on 25, there's fine. That's fine. Just public void traverse. And then traverse, we'll come back to what's actually passed in. So what we'll do is we'll go to after line 40, for example. Do you know what? Let's do a really simple version first, and then we'll get to fancier stuff later. So on 26, inside those brackets, write action with a capital A. Yeah, and then inside of the angle brackets for that one. So do the triangle, yeah. And now do node T inside there. There'll be a lot of this repetition of node T, unfortunately. Then this is part of the whole making it generic, but you'll see why that's valuable in a sec. And then just call it visitor. And then here on 29, right, visitor question mark dot invoke. Oh, dot question mark dot invoke. Oh. Yeah, and we're going to pass in the word this. Yeah, and then on the next line, why is it not like that? We are a node T. Am I missing? Oh, it is working. Cool. So next, we're going to say for each bar child in this. And then we're just going to say visitor. Actually, sorry, we're going to say node.traverse or child.traverse because it's child in this case. And then we're going to pass in the visitor. And so this is actually where all the magic happens, even though it doesn't look like it. So what this little simple function is actually doing is instead of what you were doing before, where you're saying, hey, list, do you have a list? Get me your list. Let's go through the list, whatever. What we're doing is this due to the way lists work, means you hand an action to a node and you say, just do something. And what that does something, does that thing for itself and then all of its children. And so you don't actually have to know what the children are. Now we can get to a more fancy version of this and I'll show you my demonstration from my file system later, but this is just the general philosophy of what we're doing. This is where all the magic will mostly happen. Okay. And so that's honestly, that's basically the entirety of a fairly functional basic list working now. So we can test this and then we'll start doing kind of fancier things with it. Oh, and tree, let's go back to tree actually, because we should probably just pop a root node in there. Create a node of T here and call it root. Yeah. Yeah, that's fine. Yes, and Then inside here, make an add function. Just public void add. And it's basically the exact same as the one on 24. Yeah, only the difference is now we don't have the list of nodes. We have a node, a root, so we can just say root.add new node.
All right.
There we go. And then the last bit, just for a bit of fanciness so that we can actually see what we're doing, is I like to give nodes names and they'll just default to something. So for example, let's go to 21, for example, and we will say public T data. And yeah, I agree. This isn't a conversation on generics. This is just using them to demonstrate a point, because I have to balance the fact that Andrew wants to get stuff done versus learn stuff. And so I'm being pragmatic about the fact that there's a value in learning the concept of lists and trees, but the pragmatism is like, we don't have time to spend 2 weeks to go down a rabbit hole of explaining generics. So I'm skipping generics, but covering trees, and then generics, because I trust that because Andrew plays with this stuff more than anyone else here, he picks it up transitively faster than I did. And so by giving him a tool which has generics in it, he's in a better position to pick it up than stopping and pausing to teach generics. So there's a pragmatism involved here. So I agree with you, but this isn't like a lesson. This is someone getting work done, and I'm trying to help them along. So.
And to be fair, you're both right. I need to know more about generics. It still confuses the hell out of me, but I understand it a bunch more than I did a year ago. So, baby steps.
Yeah, exactly. So no brackets on this one. It's just public and space the letter T and then space data. Oddly enough, just to confuse things, it is slightly different syntax and everything else. And we will say, just do curly brackets get and set on this one. Probably not how I should do it, but I don't care. We'll do it. We'll do a quick and dirty solution for now. Yeah, that's fine. And then in 26, right, CTOR again. Or yeah, there's fine too. And this time take in a T inside 28. Yeah, just the letter T alone, and then space data. And then we're going to say on 30, data equals data. So capital D data equals lowercase data.
I see.
And then last but not least, do a public string name on 22. Yeah, capital N, and we'll do get and set on that. And then on 31, we'll just say name equals data dot to string. Yeah. So that's basically all the plumbing we need. There's one last bit just for niceties. We can give ourselves a count just so it feels more like a real list. So on somewhere, again, say beside name, just do public int child count. Yeah, and then in this case, we're actually going to just write an arrow. So child count lambda, and we're just going to say children dot length, or count actually, because it's a list. There you go. Yeah. Yeah, there we go. So that is now the full plumbing for a basic list. There's obviously fancier toys we can do, but this is everything you actually need to have a fully functional list. And so now let's just make a test class to demonstrate this idea. So I would say pop into Unity, make a game object, and we'll just use this to demonstrate something. So make a new empty game object, and we'll just call like test the list. Yeah, and we'll just call a script test list or something. I should say tree rather than list, but I'm whatever.
Good point. I agree with you. I'm going to change it. Whoops. All right.
Cool. Yeah, so for this, we'll talk about, so first of all, before we use the tree, pretend just right now, you're making a list and it's storing 4 words in it. just the word A, B, C, D or something, the letters. So just make that as if you would normally, just making a list.
Okay.
Want to demonstrate, it'll feel less, after all the crazy stuff we've done, it'll feel less scary if we just do it as a simple reference. Yep. And then just give it four words or whatever. Mm-hmm. Yeah, there you go. So this is kind of the intrinsic relationship you have with using a list, right? You instantiate it, you pick the type it's going to be, and then you add stuff to it, right? And so now we're just going to do the same thing, but for our tree. So on 10, this time, do tree string, tree equals new tree, right? Very similar to the list convention.
And this is going to be actually modules.
Oh, sorry, module tree. Yes, exactly. Annoyingly, I would like to just call it tree, but Unity specifically has something in it called tree, and it shouts at me, and I don't want to fight with Unity. So
fair enough. Nor do I.
Yeah. And so in this case, we can add a bunch of things to the tree. Only we can do this in multiple ways. So first, what we'll do is we'll keep it simple. And so pop back into the tree for a second, and I want to add something just to make this easier to use. So what we're going to do is, yeah, here's what we're going to do. Make a new method on line 11 and go public node T and add, and it's going to take in T and then item, space item or whatever, yeah. And this is going to say var new node equals, and then new node T. Yeah, and inside the round bracket, it's going to pass in the item. And then on the next line, you're going to call add and pass in new node. Yeah, and then on the next line, you're just going to return new node. So that'll simplify adding it. And now copy that whole thing and paste it into the node as well.
Down here.
Yeah. And we only do that so that there's a way of now adding items easier, which we'll see in a sec. So let's pop back over to our test. And so in the same way you've done here, we can now say tree.add word 1, tree.add word 2, tree.add word 3, word 4, right? Basically the exact same thing.
Sure.
So functionally, it works the same way. But there's one interesting thing about this is because this is a tree and not a list, we can take, for example, word 3, and just in front of that, write var node equals in front of word 3 on line 22. Oh, and there's a request to zoom in on the code a bit.
Even more? I zoomed in a little bit. That could be a part of the delay.
Yeah. So the point is now, you've just made a collection of 4 things, just like you would with a list. Only the difference is you have another thing now. You have this thing called a node returned back to you from the one you added. And if you jump down past 23, you could say node.add word 3.1 or whatever. And you've now added that as a child element to word, right? Mm-hmm. And so what we can do is, as an example, now that we've done all of this, we can interact with and print this. So the way I like to do this to make testing easier is instead of start, name this something like build tree. And then we'll do another function on 26 now, we'll just say print tree. Yeah. And this is where we can probably tidy up the way we are doing the visiting. And I'm trying to figure out a way to do this that'll make it easier for you to use. So let's pop over to modules tree. And we are going to make, right at the bottom of this, we're going to make something called a visitor. And this is a visitor pattern. I wouldn't worry too much, but it'll simple enough. So if we write interface, visitor, or iVisitor, yeah. And the visitor of type T. And then we're going to make one function called visit. So it's going to be void visit. And it's going to take in a node of T. And call it node. And then it's going to have a comma and a second parameter called depth, or int depth.
Okay.
Which we'll get to in a sec. Yep. And now, see the function we have on 55 where we traverse?
Yes.
We're just going to copy that, the whole thing. And instead of passing in action node T, we're going to pass in an iVisitor T. So you can just copy and paste it and then swap it for a visitor. Yeah. And, oh, you have to make it on 84 has to be public.
Ah. Yes.
And so we now have a visitor, and what we're going to do now is instead of calling invoke, we're going to call visitor.visit. And are we in the tree or in the node? Scroll up for a sec. I'm just curious where we are. We are in
the node.
We're in the node. Okay, so if we scroll back down, after visit, we want to put a comma and put depth on line 64. We're nearly done, by the way. So on 64, into depth. And now you can pass in visit and then this comma depth right there.
Right here?
Yep, visitor comma depth. Comma, sorry.
Comma?
Yeah.
Ah, I see. Got it.
Why is it not liking that? Did we not?
So type it wrong.
Oh, sorry. We're visiting the node. My mistake. That's this, the word this. Visitor, visit this, and then depth. And then for child, it's child.traverse, and you pass in visitor comma depth. Yeah, and we're going to say, to confuse things, depth +1.
Okay.
Don't worry, this will all make sense soon enough.
I'm sure it will.
And then last but not least, scroll all the way up to the top, and we're going to go to the tree now. And in the tree, we're going to add a traverse method here. And it's going to be slightly different. And then I promise you we're basically done. So traverse, and in this case, you're going to take in the iVisitor T. Yeah, and visitor, yeah. And inside of this one, you're going to say root dot traverse. And you're going to pass in the visitor and comma, and this time it's 0 because this is the root node. There is no depth presently. So that's it. Now we can pop back over to our test and we'll do the first demonstration of what we actually built for ourselves. So now we have this thing called a tree and we can traverse it. Now, the cool thing is, because of the nature of how lists work, you could actually do, for example, if you write now for each var in tree, actually, I might have to add that. Yeah, let's do that. For each var node in tree, and that'll give us an error. But there's one thing we have to do for that. So pop back over to the module tree, and this top one 8 needs to be IEnumerable node T. And yeah, that needs to be in brackets as well. So IEnumerable bracket node bracket T. Yep. Yeah, and then Alt Enter that. It'll create things.
That's right.
And then you can write. I think you can just return root. I could be wrong, but it should return root. Should work, right? Or is it root.getEnumerator? It might be root.getEnumerator. Yeah. There you go. Cool. So now we can pop back over to test tree. And so we'll do this in steps. So for each node in tree, you can just write now debug log node.name. Yeah. And what we'll do is we'll do this really simply for the to make it easier to test. So capital N for name on that.
Oh, that's right.
And then so just delete the word list stuff from 14 to 17, and we'll just stick with the tree. Yeah. And then after the last line of that, 3.1, just write print tree. That way it builds it and prints it. Yeah, and then finally on above line 12, we can write context menu and then say test. And that's in square brackets. Sorry, the whole thing. It's square bracket, context menu, test, round brackets in the middle. I know the context is confusing on that.
This is one of the things I would just copy paste from something.
It's entirely fair. So with all of that done, now we can pop over to the inspector and we should be able to actually test this. So if you click on the script, so if you click test the tree there, if you add our script, because it's currently not on it, test tree, yep. Now, if you right click and click test, apparently we'll get an error. I guess we forgot something. It's not what I was looking for. Okay, double click that. What's the error? Oh, did we not assign children? Okay, that's probably. Oh yeah, I see what's going on. On 59. Just right at the end of that, full colon or yeah, and then write this and then round brackets. One of those annoying quirks. Just so try it again. That should work.
I say that all the time.
Yeah, writing code on the fly with people watching is always a little bit daunting. Yay, okay. So it's not very sexy. We've basically gotten back what a list is. So right now it's not very impressive. It's showing you word 1, 2, 3, 4. And it's only showing you level 1 because that's all we've got in a list. But the whole point of this entire exercise is you're no longer bound to one-dimensional stuff. So here's the thing. If you go back now, rather than having to do the whole thing.sublist.sublist, what you can actually do is see where we've got our for each. So go back to our test. You can now, on 28, do for each again, and then you could say for each var child in node. And so what you could do is you could say debug.log node.name, then debug.log child.name, and it'll print the parent and the child. And you want to print that one outside the for each, the first one. So it's for each, print it, then for each child, print it.
Makes sense.
Okay. So now if you print that, so now you get in sequence 1, 2, 3, 3.1, then back to 4. Now that's fine, but that's again just like what you had before, just a bit of a nicer syntax. What you could now do, because we have this concept of traversal, you don't have to write that yourself manually. So now instead of that, above line 26, we can just write, let's say for fun, tree.traverse, and then just write debug.log. Now here's the thing, delete the round brackets on that. So it just says .log. Does that work? Yes, we just have action exposed actually. Pop into the tree again, modules tree. I thought we copied that. Action, oh, it's action node T, not action T. Right. So yeah, sorry, go back to the test tree there. So that has to be a function that takes in a node. So I would say after 35, do void print node. I'll actually make a second one of these to make it easier for you afterwards. So yeah, print node. And that takes in a node of string.
Okay.
Because that's what we're using at the moment. And say node or whatever. And now you can write debug.log node.name here on 39. Oh, sorry, that's print node now. So tree.traverse and then just write print node.
Oh, I see.
Yeah. You don't need the round brackets. Literally just print node. It'll figure it out. Yeah, don't need those.
Oh.
So that should work. I don't know why it's not. What's this thing wrong with that? Hover over that one for a second. Parameter type. There's 2 parameters. So F12 on traverse. Maybe I didn't make it public. It's probably I did make it public. No, it's not that one. Go to modules tree. I'm very clearly just missing an overload here. Yeah, okay. I guess I didn't add the function version. Okay, so on 28 here, we're going to copy this. There's one in the node we want to copy here. So if you scroll down, there's 2 traversals in node. There's only 1 in tree. So you want to copy the other one, that one there. So copy 70. No, the one above it. That one there, yeah. So copy him, paste him in here, yeah. And now delete all the contents. But what we're just going to do is call root.traverse and pass in visitor. Yeah, and then just for extra fun, I'm going to do this one more time because I want to make sure every base is covered here. Scroll down to the other 2 traversals, and we're going to copy that top one, 77, one more time. Yeah, and yeah, paste it there. And also, we'll first we have to add it to the bottom one. So back down to the other one where there's 2. So paste it right beside that. That's to go in the node. So yeah, paste one more here and change it to action T instead of action node T. And what we're going to do is invoke this.data. So where it says this, write this.data. And yeah, it should be capital D. And that should be fine. And then scroll up and we'll do that third one, the top. Yeah, exactly. Copy that. And that should now be root.traverse, and that should be a T. So traverse, it should be T visitor, not action. Oh yeah, that's fine, yeah. And then so delete the contents from 36 to 39. And then now that's just root.traverse visitor.
I see.
So a bit of that's overkill, but the reason we did all of that is it'll be simpler when we do this. So if we pop back over to the test tree, now what we can do is the 2 examples. So we can now delete 27 down to 34. And first we'll run this. And then on the, 32, debug.log node.name.
I also stopped eating tasty food at work, Aaron, and started walking instead of going on the train for an hour every day. And that worked. I don't want to go back to work.
Right. So hopefully you'll notice now that we're basically doing the same thing. We're printing out the list of elements, only now we don't have to do for eaches and for eaches. There's also null because the top one is null, but that's to be expected because there's nothing in the root data. But we could assign something to it if we wanted to. So the only reason I demonstrate that is that we're now doing the same thing we were doing, only we're now doing it without having to do for eaches, because what we're doing is we're passing that down the chain. And then the final version of this, just to keep it simpler, is if you go back to our test again. Now, instead of, we'll do 2 versions just to prove the point. So now in 26, we can write debug.log instead of print node. So literally, inside the brackets. So tree.traverse debug.log. You can delete the round brackets. Why is that not working? Is it because it doesn't take a string? That's infuriating me.
I've never seen doing that.
Yeah, it's an action thing. I won't confuse matters then. I guess then the last one I'll do is I'll do an actual visitor now. So after 33, write public class print the tree. We'll do a class for this one. Now this is very much like the handler we did before, only this is now handling the concept of doing a job. So lowercase c for class, and it implements visitor of string. It might be iVisitor, sorry.
Oh yes, that's right.
Yeah, in curly brackets. And now it'll ask you to implement one function to do this. So I'll pause to explain what we're doing here. So we've now got this concept of a tree. A tree is like a list, but it's a list which might have sub-lists all the way down the chain, turtles all the way if we want to, right? And oftentimes, if you have something like that, you probably want to interact with each element in it. Like if you're drawing a tree, you probably want to draw every element in the chain of that tree. And so rather than having to expressly say for each thing and thing, and for each thing and thing and thing, what you can do is just say, look, take a walk through the tree and hit every node on the way down. And as you do, let me know. And what this method will do is it will call that function every time it hits a node and tell you how far it is. So for example, at the root, you'll get back the node of the root node at position 0. Then you'll get word 1 at position 1, word 2 at position 1, word 3 at position 1. Then you'll get to word 4, or sorry, word 3.1, which will be at position 2, because it's one level deeper, right? So this gives you all the information you need to like do a thing with a tree. Like if you wanted to draw your tree out and draw out all the sub elements, this is everything you need to do it. And just to prove that, we'll do a really simple tree drawer. So if you go above line 38 and do a string builder.
A string builder? Like
string builder
like that?
Oh, it's all one word. Sorry, it's a type of thing. It's called it's like a string, but it's a cool thing that makes building strings slightly more performant. And call it builder, I guess. Yeah, and then semicolon, and then do a constructor, so CTOR. Yep, and then builder equals new string builder. Yeah, and now here's where the magic comes in. On 48, what we can say is let's go with builder.append. And this will be some wacky syntax, right? New string. And then in round brackets, do 2 single quotes and do a dash in between them. And then go right to a comma and type depth multiplied by 2. And you'll see what this does quite easily in a sec. And then on the next line, write builder.append new line. Or append line, rather. Append line.
What is that a thing? Ah.
Yeah, it's a thing. And then node.name. And yeah, capital N for name. And I guess that's probably fine. And then after 50, write override to string. And you can return builder.toString. Right, now to test this, if we pop back up to our print function, so with a print node, you can delete that function. You can just delete that. We're not going to use that at the moment. We'll keep the print tree function. We're just not going to do the internal bit. So delete that line and then delete 30 to 33. And so now we've got like the powerful function for this, which this will demonstrate what all of this was for. So okay. On 27, write var printer equals new print the tree. Yeah. And then on the next line, write tree.traverse and pass in the printer. And then finally, on the line after that, debug log printer.toString. And hopefully, now there might be a null, but we'll see. Let's give this a try.
All right.
It's also probably an easier way to debug this in a sec, which I'll demonstrate, but yeah, so click that, it'll show up in the bottom part. So you'll now notice you've actually got this like depth indicator where it shows you that these are actually nested underneath each other. So if you had a more complicated tree, it would obviously, it'll demonstrate it clearer. But at least I hope the point is clear now that you're getting, just by passing something into the tree, you're hitting every node on the way down, and that number depth tells you where you are. And because we're printing effectively 2 dashes per element, at position 1, you're getting 2 dashes. And once you hit the next level, you're getting 4 dashes. And that's why it's nested in deeper. And so it's kind of a way to draw the tree. And the reason we did all of this is because you now have a way to effectively go through a collection of things where fundamentally it's structured differently. It's not a list. It is literally a thing which might have between 0 and whatever children, where each child might have between 0 and whatever children, and that scales. The to use it effectively, there's other tools, but I guess the point is this is a tree. This is everything. This fundamentally is, at a base level, all a tree is. It's like a list, only slightly different. The difference is, rather than being a linear set of things, it is a set of things where each thing has a list of things in it. So before we go any further, take a quick peek at the node and tree class and just give it a scan and see if it makes sense. Now, you can ignore all of the nonsense stuff about enumerators and all the other stuff. The main thing to notice is just the way the list works and the way the traverse works. So I'd say either, just take a read through that, and then we'll jump to the next bit.
Okay. I'm going to read it sort of out loud. Okay. Mostly I'm going to be mumbling to myself. Okay, so root is a new node. That's the first node. And a node, add an item. I gotta turn my own voice down. Okay, let's see. New node, and add node, new name. Root, add new node, add new node. Wait, this comes here. New node of that type item. Okay, maybe I understand that. Traverse.
Now, just to reason through what traverse means in this context, think of it like your game. You've got a bunch of you've got a map to treasure, and you've got a bunch of nodes, which are basically towns to visit along the journey to find all the clues, right? And then when you get to one of the towns, that town might have 5 buildings you have to visit to get that information. And so all traverse says is basically take the journey. Start at the first root node of our path and visit each of the towns on my journey. And if one of those towns has a bunch of buildings you have to visit all of those buildings before moving on to the next town.
Okay. And these all 3 work together. So this one is calling...
all 3 of those are completely separate. They're just different ways of doing it so that you'll have an easier time using it. The only one that really matters is the top one on 24. That's the kind of powerful one that gives you all the fun features. I only added the other 2 so you could basically say, I don't care how deep we are down the chain. I don't care what position we're at. If I just want to print the names of all of the nodes, or if I want to aggregate, say for example, this isn't a tree of strings, but it's a tree of stats, and you wanted to say, get me the total across this whole tree, you could just create a visitor which hits every node and said total is current node plus equals value plus equals current node amount. And you don't have to care about whatever depth or how it works. That will just hit every node on the way down and give you the number, and you can aggregate it out in a way that's a lot easier to work with than having to get lists and sub lists and averages and adds and whatever. So I just added the others for helpers. The one you'll really be using is the 24 one. And that's basically saying pass in something that's going to walk through the tree and do something cool.
Okay. And this calls root traverse, and that's down here. And that's what that confused me a little bit. Didn't notice that.
Yeah, so root traverse is basically the tree. The only reason the tree, it's weird to think, the tree doesn't actually need to exist. The tree is just a way of making access to nodes simpler. So I would say you could almost forget the tree class exists and just focus on the node class, because all the tree class is doing is saying call the node class. Every time it says root, it's just saying do the thing the node would do. So I would say just focus on the node class to kind of get a handle on it.
Okay. So it can have any number of children, which makes sense. Okay. Child count for later. All right. So there's a lot of nodes here, different types of nodes. So this is a list of this type.
Mm-hmm.
And where does this come into play?
Another way to phrase this is to say, I have a box and I can put some stuff in a box. But what if the box has a smaller box in it and I can put some stuff in that box? And maybe I put some smaller boxes in there to make it easier to sort. So it may be complicated having nodes, but all it's really saying is there's a box. Does it have any boxes inside of it? Maybe. If it does, do those boxes have any boxes inside of it? Maybe, and so on. Think of it as like an organizing technique down the chain.
Okay. And this was just for printing out the name. Is that right?
Yeah, that was just so that we can actually see what we're printing. Because from its perspective, like, you're going to use this for not just strings. You're probably going to use this for stats or other complicated nested objects. And so just by giving it a string, it lets you sort of see it effectively.
Okay. And this invoke is... What is this invoking?
This is invoking
node T passing the visitor.
Yeah, that's the function you pass in. So if you wanted to pass in a method that says hit every node and do something, this is just a function to help you do that.
I'm not really getting it. I'm getting like a little bit of it.
Well, the only ones that really matter is the concept of it. It is a list of lists for all sort of intents and purposes.
I get that, if I like, I'm thinking if I'm going to use it by when I have my stats and skills, I will say this one, whichever stats and skill will have a root, and then the first level of things that directly affect it. Next level, each one of those will have a list of the things that affect those, and et cetera, et cetera, et cetera. So I should have one method on the stats and skill that say, give me the children of this one, the ones that affect this, and then just every time I add a new node, run that to add nodes of all those children, et cetera, et cetera.
Mm-hmm.
Okay.
I guess the way to phrase it is that this is sort of again, think of it like an alternative to a list. It's for, you can treat it exactly the same, other than it is using a different way to store the data. It still lets you get at the data as if it was a list, only because you're using it as a tree, you get extra ways to kind of talk about and interact with those elements.
Okay.
I'm going to pull up an example here that sort of hopefully makes it a bit.
Want me to stop sharing?
Clear. Sure. I was showing this to somebody else earlier and I broke it, but I was demonstrating some ideas, so I had to quickly fix it before I can just show you. You've already seen it anyway. It's the little tree, the custom console thing I showed you.
This is from Wednesday night?
Yeah. But it's literally using that exact principle. And so I can show you where your example, the logical conclusion is, by showing the thing that I've got here. So let me see if this will share.
Oh no.
At all. I might have to actually send you some, if you don't have it to that.
Nothing's working.
Let's see if I can cut down any. Well, screen share. Am I still here? The internet's dropped out.
You're sort of here. Yeah. Oh, I think you're back. Or not.
Okay.
Oh, there you go.
Yeah, so you have to enable share on Zoom. I can't I can't.
All right, talk again. I think you're back.
Okay. Am I here?
Yes, yes.
Okay, you have to enable screen sharing on Zoom because I can't
Oh,
share.
how do I do that?
If you hit the little share thing, there's like allow multiple something something.
There we go. All right, try now.
Cool. Let us see.
Perfect.
Cool. So this is probably going to be pretty chunky. I don't know how valuable this will be to share, but we'll see if anything comes of it. If not, I'll send you a little Unity package and you can play with it yourself. So I guess to start with, we'll just talk about the idea of, because we're talking about trees, and if you want the perfect example of a tree, you've got the hierarchy. The Unity hierarchy is literally a tree, right? And so you're already familiar with going down through this hierarchy just by the nature of using Unity, right?
Mm-hmm.
And so all of the principles we talked about are no different than calling either get component or get component in children. That's literally all we're doing. And when you call find, when you call it like game object.find, spoiler alert, you're doing a traversal. You're going through the elements in order to find the one you want. And so when I wanted to make my own version of the hierarchy, and because I don't think they expose a way to do that, there is a way to override these elements to redraw them, but there's not one to like make your own tree. I had to make a tree class. And so that's what I did. And if I clear all of the various flags and settings and go back to all of the usual stuff, here is a tree that I made that is just using a tree class to redraw the Unity hierarchy. And that it, while it looks kind of cool, it's like, oh, there's the scenes up here. Each of the scenes have game objects, and each of the game objects have components, and each of the components have the scripts, and each of the scripts have fields on them that may or may not be null or empty. So that's all it's doing, and these are all the individual fields per script as well. So if I expand this out to the maximum thing, you'll see that's there is on this transform here, on this script called simple ship, there is two scripts, simple ship and player brain on the character game object. And so you'll see here, character game object with a transform and two scripts, and those scripts have a bunch of fields on them. So all I'm doing is drawing the contents of the scene. And to show you how that's done, because that's kind of where the point of this exercise is, I have a feeling I'll have to zoom in a crazy amount to make this show up, but we'll see. Let's go with graph tree. So this is my tree. And you'll notice it's very similar to the thing that we just did. The only difference is I called it graph tree and not tree. And I called it tree node and not node. But other than that, we have a name being passed in. We have an add function that adds to the root. We have a traverse function that traverses. I just added a few extra bells and whistles, but fundamentally it's the same thing. And then I have a refresh function for my own stuff. But literally it's the same thing. And if I go into the node, you'll notice it's just got a traverse function. And if I go down one more, because again, I've got a couple of extra layers on this one, but it is the same idea. At the heart of all of this, it is just a list of nodes, and it's got a new list made, and then I have an add function. I'm just doing some other stuff like setting a parent and doing some other extra things that I need. And then for the traversal and stuff, same thing. I'm doing like, where's my traverse function? Let's go to a simple one like tree node. I'm doing exactly what we did. I visit this node, and if I happen to be including the children, for each child, I visit that node and pass in a visitor. So I'm doing the same thing that I showed you, but the difference is, so we'll demonstrate how I get to this point. If I create a validation window, so actually no, we'll do a maker to demonstrate this. So you've seen the actual result. The result is this hierarchy over here, which looks like a unity hierarchy, right? And that looks pretty complicated, but how do we build that? How do we get to that point? Well, if we go to this builder thing, I've got this thing that says create graph tree. And how do we create a graph tree? Well, we create a tree just like we did, and then we do add scene nodes. What does scene nodes do? Well, for each scene in the scene manager, add to the tree a scene node. And what does adding a scene node mean? Well, you create a scene node, and then for each game object in that scene node, add it to the tree. And then we add a game object node. What does adding a game object node do? Well, we create a game object node, and then for each component on that game object, we add it to the node, and then we return it. And then for each component node, how do we do that? Well, for each mono behavior on the game object, we add it, and so on and so on. So you'll notice it's not doing anything fancy. It is just saying, for each of my children, add it to the tree. And for each of his children, add it to the tree. And for each of his children, add it to the tree. And the end result, you end up with a data structure that's not flat anymore. It's not just a list. It is encapsulating the actual relationship of there is a thing with these children, which have these children, which have these children. And the part where this finally all comes together is the visitor. And so if I want to do something to this tree, we'll get, this is where the kind of the magic comes in, is where we do a fancier visitor than the one we just did. But if I show you here, graph tree visitor. So this is my visit function. And again, it looks like a lot of stuff, but it's not really. So we've established there's a tree. So think of the unity hierarchy. Forget about my codes and my tree and stuff. Just think of the hierarchy, of the unity hierarchy. These are the different kinds of things. There are scenes, there are game objects, there's components, there's mono behaviors, or there's fields. They're the things in my tree. And so I am passing a visitor through the tree. I am saying, here's the thing that hits every node on the way down. And I am giving it a bunch of methods. And I'm saying, if you happen to be a scene, call this function. If you happen to be a game object, call this one. If you happen to be a mono behavior, call this one. And so what I get as a result is I get this thing that passes down the tree, and I can respond uniquely to each type of node that I get. So for your case, that might be, you might have a party which has a bunch of characters. Those characters might have stats or abilities. Those abilities or stats might have substats or abilities, which might have compound or child stats and abilities or whatever. And you could pass a visitor and say, hey, for every stat, regardless of which character it's from, just every stat, aggregate it if you want. Or you can do something interesting like count the number of fire. Like you could say, for every stat, that's fire, count all of them and add it up and do something unique with that. And I'll demonstrate how I'm using this in a second. So if I show you, first of all, this drawing I'm doing, this drawing is a traversal. I'm saying hit every node, and if it happens to be a scene, draw it like this. If it happens to be a thing, draw it like this. And I'll show you, as someone who's done a lot of editor scripting yourself, you should recognize the code, so it's not that crazy. If I do a fancy editor printer, this is my visitor, and it's kind of like the handlers we've been doing. I'm saying hit every node in that tree we just made, the one we just for eached our way through. And if it happens to be a tree node, draw the node using this icon, this name, and do the little expanded arrow, whether it's expanded or not. And then if you happen to be visiting a scene, draw it with this icon, and then so on. I've drawn, this icon. And if it happens to be a Unity component, I'm doing a bit of extra stuff, but I'm basically saying draw a little button to the side of it with a question mark, which is what this is over here. But you're seeing it's just the I'm just saying to draw this, go through the tree we just made, and then run a bit of editor code for each one. And you'll notice what's really cool about this, I don't have to like I'm not writing for each element in tree. I'm just saying, in the event you come across a scene, do this. If you come across a component, do this. If you come across a mono behavior, do this. And then I just throw it at the tree. And it will just automatically go down through the tree and do the various different things. And just to demonstrate this, This is what I'm calling a fancy printer, and that's printing this. But if I go back to the validation window, there is a function here, which is called something like create visitor. Create visitor. I can just, as an example, replace this with return new simple editor printer, and we'll just pass in a hierarchy icons and true for that. Now, if I replace which printer I'm using, it's drawing a really simple tree now. Because all the drawing is doing is it's going through each one of those and hitting the node. And this one will look even simpler. You'll definitely recognize this one. This one is literally just me writing label field, editor GUI layout.label field. The only difference is I'm saying, first of all, use this GUI utility to get the icon, and then create a GUI content from it, and then draw a label field. And as for the indenting, that's me just setting the literal editor GUI indent. So all of these is code you will have written before. Like maybe you didn't use the icon stuff. I don't know if you've done this editor utility GUI. No, but... well, yeah, but it literally just creates GUI content out of a string label for an icon. It's like it's the inbuilt icons inside of Unity. It's how all of the editor stuff is drawn. But other than that, like like literally, I could comment that out, right? Like I could just do like that. So this is the only bit that matters is the label stuff. If we clear him out, there you go. So it's just a hierarchy of strings, right? It's just labels all the way down. And the only thing I'm doing is I'm indenting relative to the indent level of the tree by setting editor GUI indent to depth. And then I'm saying label field is equal to the node name. Now, in this case, I'm using the node type name, whatever. But the point is, it's like you can see all this is doing. Draw the tree node. Then for each scene node, draw the scene node. Then if the scene node happens to have children, which are game objects, draw the game objects. For the game object, if it happens to have components, draw the components. For the components, if they happen to have monobehaviors, draw the monobehaviors. If they happen to, and so on and so on. But I don't have to declare that because the beauty is that the iteration of that is built into the data structure. That's the magic, right? It's not, I don't have to go through and ask for each one of these things in turn because the literal way it's stored is in a filtered way already sorted by parent to child relationships. So when I say go through it, it already is a tree, right? Mm-hmm. Again, I know this is a bit crazy in terms of complicated stuff, so I won't dwell too much. I will just say that the reason you do it this way is because you can now start to separate the thing from the actions you do on it. So, for example, what I mean by that, if I put this one back, you'll notice that I have this thing called a visitor. And I'm also using a different pattern called the decorator pattern. And I won't freak you out too much with it. I'll just demonstrate what it is, but you don't need to worry about this. This is just kind of proving where this scales to. So first I'll show you, this is the tree and me drawing it, right? But I have a bunch of extra features. It doesn't just draw the tree. It does other stuff like I can hit this flag and this thing will turn on or off fields which are required or not. So I've got this saying that I've marked this field here. Where is it? So in here, I've marked this field as required, which means you must provide it in the editor. If you don't, it'll throw an exception and stuff will go wrong and things will break. So I've decided to draw those differently. If it's a required field, draw it orange. But if it's a required field that has not been provided, like it's null over here, draw it red, and then give me a button to fix it, right? But to show you that that's not actually crazy, like it's like, oh, that's a lot of logic and complicated stuff. How are you choosing it, which one, and how do you draw it? Well, all of that, literally all of that, is covered by the drawing filter. And so if I go back in here, and we go down to the part where I say, where's draw field node? Is it mono behavior, Unity component, field? So that's all here, where I say, I am now hitting the tree and I'm about to. I do the indent, I then say, is this node required? If it is, draw this icon, otherwise draw this icon. And then if it's null, change the color to this icon, right? So it's not doing anything too fancy. But now we get to even crazier things where I'm drawing every element of the tree. But what if I just chose not to draw some of them? What if I said, you know what, draw every node, but just skip all of the game objects? And that's what happens when I do this everything flag. If I just say none but game object, or if I say everything but game object, I can filter out which elements I'm drawing. So draw just the fields, or just the mono behaviors, but not the fields, and so on. And again, that looks like complicated. Like, how am I getting this complicated filter of multiple layers of stuff and whatever? Well, all I'm doing, and this is really straightforward, like it's kind of crazy, is this filter. This is a visitor that we made, but the visitor takes in another visitor. And all I do is say, based on this enum here, none, scene, game object, whatever, if it's on or off, I literally either draw the visitor or I skip it. So for each time I visit a scene, if it has the flag of scene, draw it, otherwise don't, right? So this may seem like a complicated filter, but all it's doing is saying the drawing you're about to do, don't do it if this condition. And the same thing goes for searches. I have this feature here, which lets me say light, and I can type a search for lights, or camera. I can type a search for camera. And this lets me do it by doing string searches. But again, this isn't a complicated feature. The way this works is over here, I'm just doing a visitor that visits each node. And here's my string one. And I just say, if the node name contains this, visit the node. Otherwise, don't visit the node. And so you can stack these one on top of another and do kind of fancier stuff. But yeah, so I'm not expecting you to like cover all of this craziness. This isn't really the point. I'm just hoping to demonstrate that if I was to ask you to build this, where you've got toggles for certain fields, levels of depth you can toggle on and off, automatic buttons that draw based on certain stuff, color changing icons, fixing various stuff, search boxes, it's like, well, that's a lot of stuff. That's got to be confusing to add, right? But if you use the appropriate data structure, I can pare all of this back. All of these are add-ons. These have been added after the fact as plugins, because the only part that really matters is the drawing. So if I go back to the simple one, return new simple editor printer, and I have my icons, and then true for that, I can just draw the basic version again. Come on. There you go. And then each one of these features is a layer wrapped around the code that's there. I say, take this thing and wrap it in a string search, or wrap it in color changing icons, or wrap it in flags and filters, or wrap it in some other add buttons that do different things. And all of this is just to say that this is the right structure for this problem. And so there's multiple data formats out there. There's graphs, there's lists, there's hash maps, hash sets, various different things. It's worth knowing all of the collections that you can play with. But in your case, the point is, if you're making a tree-based structure, stuff like this will be easier because the nature of a tree will support the kinds of behaviors you're trying to do. Because if you're making a tree, the reason you're making a tree and not a list is you probably want to go down through the children at some point. And so there's inherent behaviors in a tree that support doing that.
Yeah.
And now you have a tree to use, right? So it's more just a PSA on, if you're using something that kind of looks like a graph, use a graph. If you're doing something that looks like a tree, use a tree. If you're using something that's a stack of things on top of each other, there's literally a collection called stack. You could use a list, but now you have to start managing, am I at the top, and what if I get to the bottom? And if you use stack automatically pops one off the top and forces you to engage with it from a top-down stack of papers approach. And a queue is like queuing people up at a bank and you're visiting each person. It's the difference of what's first come, first serve, or last, first in, first out, or last in, whatever, FIFO and LIFO, whatever. The point is, there are collections to support the kinds of behaviors you're doing. And in this case, you now have a tree you can play with, is effectively the point. And it's a swap-in replacement for what you're doing with lists. It just has more features.
Cool. I think I will have to, play with it, essentially. I make it work and then see what happens.
Yeah, yeah, and there's obviously like we'd have to get to some points like serialization because I mean it is just objects, and if you mark the node as serializable, you can serialize it. It'll just serialize like anything else. But there just might be some extra concerns with the saving systems and stuff you've got. But I would say that using a custom collection will make your life, even if you just use it for editor drawing, even if you store the data as a list, but then before you draw it in the editor, you iterate all of your stuff and say for each character, add character to tree, for each character's stats, add the stat to the character node, and then for each stat, add the whatever, and then draw that, not the list. You'll now have a thing you can draw and play with that's structured to like your editor tool, you know?
Mm-hmm. Yeah. So this stuff is all right now on the scriptable object. So unless if I mean I might use trees then at runtime, but the stats and skills in this context are scriptable objects. Mm-hmm. So they don't need to be serialized at runtime.
Okay.
Yeah.
Yeah, cool. So that's a bit of a tangent, like I said, and I don't know how. I understand it's not easy to just swap in a replacement to a complicated new data structure. I'm not expecting it to replace the stuff you're doing, but it should hopefully highlight that there's something there, right? There's a difference in the way that works in terms of why that might be valuable to you.
Yeah, and I'm gonna replace. I mean, for this portion of the stats and skills, basically knowing does this, what affects this, and mm-hmm. excluding that from another list is what the goal is. So I think this will do a really good job there, and then I'm sure I'll find places to use it elsewhere, and I'll abuse it, and then have to walk it back, like I've been doing with Link all week.
And another thing too is down the line you're going to hit the same problem but with graphs, and so the idea is list a flat list of stuff, tree, lists of lists, and then the last one is graph, which is where you've got something like you're doing AI that's traveling over waypoints. Waypoints are traditionally not A to B to C to D. In most games, it's like a network of safe nodes, and sometimes they connect to each other, sometimes they skip around, and they kind of build literally a graph of nodes. And you get into the territory of oftentimes the behavior you want is like find the nearest node to the shop, or find the path between me and the next quest marker or something. And if you use lists, you have to go down this crazy road of for each possible node near me, then for each possible node next to that, what do I do? And you start going down this, like, how do I reason myself from here to here? But what a graph does is it literally says, from this node, where can I go next? And the only places you can go are the connected nodes. And so you're not querying all the objects, you're walking the path of the nodes. For an example of where this gets quite clever, if you have AI and you could say position A, position B, walk from A to B, they're obviously just going to walk in a straight line. But you might want clever AI, which says, hey, hang on a second, that's uphill and that's a bridge. Uphill should be harder. The bridge should be the preferable choice. Even if both nodes are there, you shouldn't just walk in a straight line. You should pick the better route. And so the concept of an A-star pathfinding is on a graph. And the way that works is every node is given a position. So there's where I am now, the bridge, my target, and then top of the hill, my target. And so you've got this graph with a branching thing. And so I'm at my position. I want to get here, and I've got two ways to go there, up the hill and over, or across the bridge and over. How do I pick? Well, what you can do is you can actually put a number on the line and say, this is a difficulty weighting of 1. It's a heavy climb. This is a difficulty weighting of 0.2 because it's a simple walk across a bridge. And so when the AI is trying to pick which way to go, it picks the easier path to take. And so the point is that, like, that's nothing you couldn't do by just having lists and doing different searches. But the way a graph works is it actively encourages you to have things with data about the relationships between the things. And you can start doing things like a great one is if you had your upgrade tree, you can basically say, oh, well, you actually need to have this one before it unlocks these. Like there's a tree structure to these. If you do it in a list, you have to keep doing checks. Well, you can't unlock this till you've got this one, and you must have had this stat to unlock this one. But if you structure it in a graph or a tree, then you could just say children are not unlocked until parent is unlocked. And so it physically won't let you do these until this one's done. And so you don't have to write any code to say, have you unlocked the prerequisite supported whatever? You just build the tree. You say, you need to have crafting level 1, crafting level 2, crafting 2 can be like special crafting, and then magic crafting, whatever. And then all you do is say, for each current node, draw up to your current level, right? You don't have to say anything fancier than that, because whatever the path, as far as they've gone, it'll auto draw. And if you say, if they unlock one of these nodes, then like you can just put a flag on each node and say, this tree node is unlocked flag. And if it's not unlocked, the presumption is none of its children are unlocked either, right? Mm-hmm. And so it may seem like the same thing, but like imagine how much logic that saves. You're just saying, draw all active nodes in tree. And then as you decide to add more nodes to the tree, you intrinsically already get all of the security and gating and extra features. And you can have an event that says, on node activated, do something. And now you don't actually have to do anything. You just say, whenever a node is activated, add stat values from whatever's on the node. And suddenly you don't have to do any of these iterative checks through nested stuff and calculate things. You just say, hey, here's a tree. It's a tree of different hierarchies. When one of them activates, let me know, unpack whatever data's in it, and I'll apply it to the character. And suddenly like your code becomes a lot easier to work with,
Okay. I'll have to keep that in mind. I think the graph sounds like a good use case for quests that are very much not linear,
Yeah. Well, that's also how dialogue paths are done too. Like you'll often have the thing of meet guy in woods. Have you seen the wolf yet? If you have that dialogue option, if you have this dialogue option shows up, then you've got 3 different choices. If you pick this one and it goes down this path, and then the beauty of a graph is graphs can be what's called cyclical or acyclical. So you have those dialogue options where you exhaust one path, and then when you're done, it returns you back to the top and says, hey, so what you want to do now? And then you can do I picked up those things for you. Thank you. Here's your money. Done. Back up to the top. And then you've like different options. You can turn these off as you go. And so the graph sort of naturally self-corrects. And then if you could have then things like a shop which gives you a discount. And you could say, kill the wolf that's attacking, whatever. Here's your discount. Thanks for the help. Or you could have the murdered his wife on a different quest. Thank you. I wanted to get rid of her. Here's your discount, right? You could get to the same point by doing different paths because a graph supports that level of structure. And you don't have to write all the complexities. You basically say, there is a node called start. There is a node called has discount. And there is a path called kill wife and a path called, kill sheep. And you could say connection A to B, connection B to C, and it just figures it out and you're done. Like the amount of, you don't have to do the if statements anymore,
Yeah. Cool. Well, we'll look forward to that episode at some point in the future. All right. Thanks, Jason.
Yeah, no problem. I'll leave it to you with that. I know that's a lot to play with.
It's a bit, but I think it makes sense for the most part. I just need to wrap my head around it. And I'll probably do that just by playing with it, just by tinkering around and seeing what works and trying to make it work with this one simple thing and then going from there.
I know. Well, good luck with it. I should get back
Thanks.
to my coffee. So
yes, it's early morning for you.
It is. It's nearly 7 a.m., but thankfully I don't have anything on until about 4 p.m. So I'm basically just up watching, funnily enough, all the Star Wars movies. So there you go. That's what I've been doing.
In a random order, I assume.
Of course, by random I mean literally the canonical exact order, not the not the release order, the actual. So this is a whole side note. When I was a kid, I saw episode 1 in theater. That was the first one I ever saw. So not 4 and New Hope, but actually like literally episode 1, the Menace one, because that's at the age I was. It was like that came out in cinema when I was a kid, and so that was my introduction to the series. And then I kind of I never really found. I'm more of a Star Trek guy anyway, and then I missed a bunch of them. And then I finally when the new one came out, I watched that one, and that was boring. I wasn't a fan, and so now I've missed so many of them that I'm like, you know what? Time to just Start at the start.
Wait, are you
Way to the whole
saying
lot.
that you've never seen the original ones?
Well, I have now seen A New Hope, and later on today or tomorrow, I will be watching the other two. So I hadn't. I'd seen snippets and bits, but I'd never actually done the full
Sure.
cycle.
No, this is it blows my mind because I had the opposite. I had my we had VHS with all the Star Wars. I knew them by heart when I was a kid, and when they were re-released in '97, we went midnight showing, waiting outside in a huge line to see it re-released, and it was amazing because we had never seen them in the theater. I was too young to see them in the theater, but we grew up with them on VHS. And then when episode one came out, also waiting in line. Although I had tickets, and it was a brand new theater, one of the giant theaters. When they used to be the theaters where you'd see people's heads at the bottom of the screen. This is a giant theater, and it just opened, and episode one's coming out, and I got tickets, and I'm waiting for my friend because I said, "Hey, do you guys want to go? We got extra tickets." She was like, "Okay, we're gonna come," and they were late because they didn't really care that much. My brother had snagged great seats, and they forced him to get rid of the seats, and we ended up sitting in the front for episode one. It's okay.
It's not good.
I saw episode one again in 3D, I think it was. We took my dad when he was getting pretty old and just to the movies. I fell asleep.
Yeah.
I guess I understand that people who saw episode one first, a lot of them loved it and don't like the original ones. I can't do it. The other way.
Oh no,
is
no.
the other way for me.
I have now watched episode 1, 2, 3, Rogue One, and then New Hope, and now they all have pros and cons. And I will say the originals are better than people give them credit. Well, not the originals. I would say that 1, 2, and 3, the prequels, are better than people give them credit for. But objectively, the originals are just better movies. Like, they're better crafted, they're better structured, and they're not as cartoony as like they're not as slapstick, I guess is the way I'd phrase it.
Sure.
So yeah, don't. Oh God, yeah, he's still horrible. That's not. It's definitely a still a standing fact on that one. And just to be clear, like this is an anomaly. Like, I am somebody, like, I've watched all of the Doctor Who's. Like, I'm talking the black and white Doctor Who's. I watch old stuff. Like, I watch, like, when I was a kid, I grew up watching things like I Dream of Jeannie and Bewitched and stuff. So like, it's not just, oh, you watch no, like, I watch old stuff. It's just particularly Star Wars I missed as I was growing up.
Yeah.
So.
Fair enough. Well, when you're done, you can tell us what your favorite one is, and then I'll compare it to my favorite one, and we'll see.
Yeah, okay. I will say so far it's the first one at the moment, simply because, not episode one, like the original, simply because
okay. A New Hope.
Yeah, just because from a narrative perspective, like, I don't want to get into a whole big thing about film theory, but I will say that movie is tightly structured in that you've got hero's journey, you've got the multiple characters, it's got an actual arc for each of the characters, it makes sense narratively in what it's doing. And I would say, despite what people say, episode one has an almost identical arc and is equally as well written from a structural perspective, but it was trying to appeal to kids. And so they hid all of that with all the extra crap on top of it. And so structurally, 1 and 4 are so far the best. Rogue One is a really good attempt at return to form, but it's got, like, mired in the whole Marvel nonsense where they kept trying to be funny and whimsical, and it just, the irreverent, like, why would you hack a robot and then have it act like, make goofy jokes when it's trying to blend in? It just bothered me. There's just, like, a lot of silly decision making on stuff. But I will say that they're the better narrative stories so far. And then it all falls apart, obviously, with emo Anakin, which drives me insane. It's just bad. That's just objectively just not good. But
Emo Anakin. Yes, well, cool. You've blown my mind twice tonight. So, all right, have a good one. I'll see you later.
Good luck.
Well, that's cool. Whoa, Elliot. Thank you. I will always be humble because I have imposter syndrome. And I know enough to know that I don't know anything. Or not much, at least. Thank you, Elliot. Thanks for hanging out. It was good to talk to you, and you helped me out earlier. Caught a few things, and that was very helpful. I never saw Doctor Who until the mid 2010s when it was on Netflix and stuff. David, what's his name? That was the first Doctor Who. But I think I knew of it when I was younger. I just never saw it. It wasn't as readily available as other things. All right, so now the trick is to see if I can get this working after I turn that heater off. Okay. So we have a tree, and if I copy this to stats and skills, now each stats and skills will have its own. So I guess I don't really need it. I don't. Yeah, I could do string. Just do the names. We're going to call this skill names or stats and skills tree. Okay. David Tennant, that's right. He was good. Then the next one was good too. I think I saw not David Tennant, the next one with the long face, kind of goofy looking. Saw him at a convention in San Francisco once where people from Doctor Who and people from The Walking Dead were at. And they were all selling autographs and stuff. We didn't pay for autographs, but the Doctor Who guy was... So the difference between him and Stephen Yeun was night and day. Where the Doctor Who guy, not David Tennant, but the next one, was charging, I think it was like $100 or something for an autograph. And there were signs that said, no pictures. And obviously, since it's autographs, he was just sitting behind a table, signing them, and then sending people on their way. And then Stephen Yeun, on the other hand, still alive on Walking Dead at the time, was cheaper for autographs. And every single person who came up, he was talking to them, high-fiving them, taking pictures with them, like just goofing around and just being a regular person. And then the actor who played the bad guy at the beginning of Walking Dead, the best friend who got with his wife when he was in the coma, that guy had nobody in line, and he looked pissed. He looked like his character on The Walking Dead, and he was acting like that too. And I think nobody liked him in the show, and so he was kind of annoyed because he went all the way up to San Francisco, and nobody was paying money to get his autograph. We thought that was funny. But yes, that was Christopher Eccleston, huh? I forgot his name. Yep. What can you do? All right, so we've got a tree now. What do we do with this tree? Well, let's find out. In our test tree, what do we do with it? We build the tree. Okay. So in my stats and skills, we can create a method called build tree. And in our build tree, that's, you know, if I do an infinite loop, that's essentially what's going to happen. Build tree, if we say build tree, build tree, build tree, then I mean, I guess the first thing is to add the first row and then make those iterate after themselves. So on build tree, I would say okay. Stats and skills tree dot add rain. Wow. First, let me get the ones that affect this. Now I was doing that in the other here, I think, build effects list. And so I can probably make one of these methods. Of course, I can't, well, that's fine because it's not going to be called at runtime. So I can do this. It's basically this. Let me just copy this over and make a new method called public. It's not going to be void, but effects list, and it's not what we need. We don't need skill branch, new branch. We need you know, I've never actually used well, I've kind of used HCRP, but never in a real project, only to test my stuff in HCRP years ago, and it looked good. And then it all broke. So I guess I just need a list, because that's what I'm going to return. And we need to get this. That's, I guess I'm just copying it because it's in my editor utilities, but I don't have access to this from here. I'll just have to add it there. Stats and skills array. I already added that apparently. Oh, I have utilities. Well, I forgot that I had done that. So okay, that's helpful. I still tell people when they come to my Discord about when they talk about HGRP, I always say something along the lines of, well, HGRP is for if you know what you're doing and why you're doing it, then use it. Otherwise, don't. I don't know if that's still accurate, but I keep saying it. Okay, so the effects list is going to create a new list of stats and skill, get all the trainable ones, and then if the trainable one is this one, we're going to continue. If it doesn't affect this one, then we're going to continue. If it does affect, we're going to add it, and then we're going to add all of its sources as well. Make sure this is distinct and make that to list. And then return effects list. And this is going to return a list strings, or not string, stats and skills. And then so I feel like I might be doing something wrong because I'm about to do a for each loop on this, but we'll see. For each stats and skill SS in effects list. Dot name, or dot object name rather. And then each one of those will build a tree as well. I'm not sure if I did that right, but it feels like I did it right. And if it feels like I did it right, then it must be true. Let's see. So let me select one I know is affected by things. Not skill tree. I have to make this serializable. It is good advice. It's like that song, if it makes you happy, it can't be that bad. I mean, kind of, to you, subjectively, can't be that bad. Well, it's not showing up here. I don't know why it says it's never used, but because, okay. And I guess I need to clear it before I build it, huh? Ooh, I can't clear it, so instead I go new modules tree string. That would clear it, I think. So I need to call this. I need to call this when I do many things like add. And anywhere I say build effects list is now going to be build tree, but it's going to be this object dot build tree. Or I'll have to figure that one out. So this one doesn't have this object. I think I'm going to have to add it then. All right, and this doesn't show if either of those are the true. All right, let's see if this does anything. I don't know why I can't see this. I guess it's because it's a class, I suppose. Not sure. But we can debug some stuff. We should probably just start with that, because I'm going to click a button and then come back to this anyway, so might as well start. And we're going to say tree for debug.log tree for object name as stats and skills tree count dot. We had a count, didn't we? Child count. Oh. So it's not going to be modules tree, because modules tree is just the root. So it's going to be the nodes. Dot node. What is the node? Is there a reason not to just make this a list of nodes? Okay. I mean, if I do it like this, we're never even getting into the nodes. Let's see what happens. Yeah, because it needs to do this for all. Feel like I might be doing it a little bit wrong. But again, it feels right. I do build effects lists. All I need to do is get rid of all this junk and say this stats and skill.build tree. Because it only has to do it for the modifiable ones. Okay. Now the tricky part will be the traverse. Technically, each modifiable stat and skill now has a tree with only their first level as strings. Okay, I think what I need to do is let my brain think about it while I sleep and have a drink for now. Because what I'm starting to think is like, okay, I feel like I'm getting back into using this, but treating it like it's a list. And I know that's not the point. I know that's not what I'm supposed to be doing. It can't be right. But if each stat and skill knows which ones affect it, technically I should be able to traverse through the stats and skills, and go through there. Now I'm keeping the string, the names, simply because I don't want to have massive like depth, the depth of serialization depth, I suppose, but now I'm getting to the point where I'm like, oh, well, once I know these, I should just get the strings, like return, if build tree returns a list of strings, then I could just do that, and then everyone will know what, it's just have a list of strings, but then it's just a list of strings, and that defeats the purpose. So I think I need to sleep on it, is what I'm saying. I think I need to, I'm already tired. It's 11:20 on a Friday night after a busy week and all that. So I think when I wake up, have some coffee, maybe it will make a little bit more sense. So what I'm saying is I gotta plug this in. Wow, that is super blown out right now. Usually it's not so blown out. I wonder why. Maybe if I move this light up. Whoa, whoa, whoa. That's bright. That's still bright. It's late. I'm turning that off. Or down. It's dim. But thank you all for joining and participating. Jason Storey, thank you again. For those of you who are interested in supporting Jason Storey, go to Ko-fi or jasonstory.ko-fi.com, something like that. Coffee, Jason Storey. Here we go, ko.fi. You can go to ko.fi, and I'm going to put this in the description of the video as well, because Jason keeps helping, and this is wonderful. And I'm going to sign up as well. And he needs more coffee. He's only had 332, and he needs more. So I'm going to do that. You should too. Wonderful, wonderful advice and education from Jason. So I hope you all enjoyed this stream. I will see you another time. Chances are I'll be streaming tomorrow at some point. I know there's definitely some stuff I need to do. I need to call a person, a guy or a girl. Their name is Alex. I don't know if it's a guy or a girl, so I need to call a person, assuming it's a person. What if it's not a person? Pretty sure it's a person. I need to call them and see if I can do some stuff, but yeah. So thanks everyone. Tonight's drink of choice is probably going to be either a Negroni or a Manhattan. I haven't decided what. I had a Manhattan the other night, and it was with a new vermouth that I haven't tried before. I'll have to try it again. It wasn't... There's something off about it, but... Thanks, Aaron, and Warped, and Corey. Excuse me. Have a great night. I will see you all another time. Where's my button? I'm back. I'm just proving, showing. I just did it. I'm going to put this link in the description if you feel like buying Jason some coffee like I did. All right. See ya.